Okay, hello everybody, welcome to the channel Class for All. Today we will continue polynomials part 2. Last class we discussed the remainder theorem and we discussed the remainder theorem and we discussed the long division method. Remainder theorem and long division method. This class we will be discussing the third part, which is the factor theorem. All right, and we will do remaining questions of the NCERT textbook along with some challenge questions for you to get the extra edge to understand the chapter better. Okay, so without any delay, let's begin with an example of what is this factor theorem and let's do the remaining questions. All right, so we have to find the value of k. Find value of k if x minus 1 is a factor of 4x cubed plus 3x squared minus 4x plus k. We discussed last class that if it is a factor, and in the remainder theorem we did that if this is a factor, then if I put x's value of this number, if I keep x's value as 1, then this whole part should be 0 because it is a factor. And what step did I teach last class? So the first step is you have to equate this to 0. So when I equate x minus 1 equal to 0, I get x is equal to 1. That was the step we discussed, right? So now I will just put x equals to 1 in this equation. So p of 1 is 4 into 1 cube plus 3 into 1 square minus 4 plus k, right? And we all know that this whole thing should be equal to 0. So I get 4 plus 3 minus 4 plus k is equal to 0, right? So 3 plus k equal to 0. Therefore, k is equal to minus 3. So we have got the k's value. And what we have used the remainder theorem. Okay, this is just a recap of what we did last in part 1 of polynomials, right? I hope you have all written this down and we can pick up the pace now since you have already learned the basics. Now we'll be moving on to the factor theorem questions, right? And so there'll be some terminology used while we are factorizing a polynomial, right, of degree 2 and 3. We discussed what degree is. Degree is the power of x. If x is 2, the degree is 2. If x is 3, the degree is 3. If x is 4, the degree is 4. And if it's just x, then degree is 1, right? So when the degree of the variable is 2 or 3, then we can factorize it using the factor theorem. And this of a polynomial, factorizing a polynomial of ax squared plus bx plus c, where a is not equal to 0, and these, remember, these are just constant. This can be any number, a, b, and c, 1, 2, 3, 4, they can be anything. Okay, they're just constant I'm giving. They should not be, a should not be equal to 0. Then we can factorize it by splitting the middle term. And I will explain what is this when we do questions. You will understand this better when we do the questions. All right. Right. Now, instead of proving this, let me start by doing a question so you understand it better, right? So we have a question, we have to factorize. The questions will be like this. For fact, when one question will come in your mind, when to use factor theorem, when to use remainder theorem, you have to use a factor theorem when they say factorize. So you have to break up a big polynomial, usually degree 3 or 2. So this is the polynomial they give you, right? You have to use splitting the middle term. So then you have to use a factor theorem. When they just tell you to find the value of k, or they tell you to find if this is a factor or not, then use the remainder theorem. Okay, I hope this is very clear, right? So we'll use the splitting method. I'll write it, splitting method, right? All right. So we can take any two numbers. Let's take them as P and Q. So P plus Q is equal to 17. We took the middle term. This is the middle term. Okay. So we split the middle terms is 17. Okay. And then PQ would be the product of the first term. First term means the coefficient. This is the coefficient of x. The coefficient of x square or x cube, right? So we'll have to take that product along with this constant, which does not have any variable to it, right? So I will take that and I will multiply it. PQ is equal to 6 into 5 is equal to 30. This is the method we're going to go about. So you need to note this down, okay? So now we're going to look for factors of 30. Factors of 30. This is just one method of doing, okay? This is method 1. I will tell you another method which I prefer more. This is just method 1, okay? So we'll do this method and I'll teach you both methods. So we have to find the factors of 30. So what are the factors of 30? Let me just quickly write it. So 1, you have 2, you have 3, you also have 5, right? You also have 6, you have 15, and in 13, dot, 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 dot. Okay. So the question is, out of which the pair, which two numbers, 2 or 3 or 5 and 6, which pair will give me a 17? That is what we have to look for, right? So once you write all the factors down in one line like this, okay, then you will come to know which is giving you 2 and 15. So 2 plus 15 is equal to 17. This is satisfying it, right? If you can see, nothing else is satisfying it. So we will just put these two numbers instead of 17, right? Because 2 plus 15 is also 17, so I can just replace it. Right, so let me just write that 2 and 15. So I'll just replace it is equal to 6x squared plus 2 plus 15x plus 5. I'll get 6x squared, multiply this with this and this with this, 2x plus 15x plus 5. And then what's common in these two terms? First, you will take these two terms and then these two terms separately. What's common in this? 2x is common, 3x plus 1. What's common in this? 5, 3x plus 1. And again, what's common in these two terms? 3x plus 1 is common, right? They're both the same, so I can take it outside. So I can write it as 3x plus 1. And then what's remaining? This is remaining and this is remaining, 2x plus 5. Right? And this is your answer. See, the question is not telling you to find the value of x. It's just telling you to factorize. So this is the factorized form. Right? It is all factorized. You can leave your answer to this. This is correct. Okay, this is just one method of doing this question. Okay, splitting. This is also the way of solving a quadratic equation. What is quadratic? There's 2 here. So this is also a way of solving a quadratic equation. You have to use this method also. Right? Now let's move on to another one. Okay. All right. So now we have a question where the degree is 3. Why is the degree 3? Because we have a 3 of the highest power. Right? So we have a degree is equal to 3 now. So now how are we going to solve this question? Right? Or in this case, we have to look at last constant, which has no x here. There is no x, so we have to look at that, right? We have to look at the factors of minus 120. So what are the factors of 120? You get 1. Definitely you'll get 1, 2. You'll also get 3. You'll also get 4, right? Dot, 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 dot. But only take the first 2 or 3. This is plus and minus 1. That means even minus 1, because minus 1 would also reach minus 120, and plus and also minus 2, and plus also minus 3. So now we need to put these values, and whichever will satisfy this equation, okay, whichever will give me a 0, whichever will give me a p of x is equal to 0, whichever of this, I have to use that. Okay, so this is also called a hit and trial method. So let's try it out. So let's choose 1. Okay, so now in order this to be 1, x should be what? X has to be 1, right? X is equal to 1. So but we cannot write this, we will write an expression form. So you bring this there, x minus 1 is equal to 0. So you use this now. Okay, don't just put x is equal to 1, you have to use this as a factor. Okay, let's try it out. Keeping x is 1, 1 cube minus 223 plus 142 minus 120. What do you get? Minus 22 plus 22. Yeah, so x minus 1 works. Now let's just put it. We took x is equal to 1, right? X is equal to 1 we took, which is x minus 1 is equal to 0. Same thing. So now what are we going to do? Now you can either do the long division method, or you can also take it common, right? Since we have learned the long division method, I'm going to employ that method because most of you will be easier with that, right? So let me just write it. Right. Okay, let me write a bit bigger. And I write x minus 1 over here, right? So check the first term. What's the first term? You get x square, so x cube. And then multiply the second term, minus x square. Change the sign. Remember to change the sign. You get minus 22x square. Bring 1 down, 142x. We learned this in the long division part of the part 1 of polynomials. Take the first term, minus 22x. Multiply it, minus 22x square. Multiply the second terms, plus 22x. So what do you get? 120x. Bring it down, minus 120. First term, plus 120. So you get 120x minus 120, and that will give you 0. So that is a factor. But we are only interested in this part. Now, if you see this came into an x degree 2, right? So now we can solve it the way we did the last question when x was degree was 2. So now we just have to factorize this, and we can just add those. You get 2 factors for this since the degree is 2, and since the degree over here is 3, you'll have to get 3 factors. Means 3 brackets like this. Okay. So let's factorize this now. All right. What do we have to do? We have to split the middle term. So p plus q is equal to minus 22, and p into q is 1 into 120, which is 120 itself, right? So what will be p and q? So we look at the factors of 120. You have 1 is 2, 3, 4, you have 12. Before that you also have 10. Yes, you see this? 12 and 10. So we can use this p and q, but since it's minus, we need to take minus 12 plus minus 10 is minus 22. And minus 12 multiplied by minus 10 is 120. It is satisfying? Yes or no? See, it's satisfying. So we can take it as minus 12 and minus 10. So I will just substitute it. X squared minus 12x minus 10x, because I got 12 and 10 plus 120. X common, x minus 12 minus 10 common, x minus 12. Remember to be careful of the signs. X minus 10, we took x minus 12 common. Yes, but the answer is not stopped here. Remember, you also had an x minus 1 over here when you started with. So you just need to add it down. So the final answer will be addition of x minus 1 and then these two, right? So you have 1, 2, and 3. If you have 3 brackets, 3, then it's correct because the degree was 3. And this is your answer to the factorization of this cubic polynomial. So in a cubic polynomial, you have to do an extra step. You need to do a long division method, or you can do the splitting method again and again. But this method is easier and I prefer this method. So if you would follow this, it would be much appreciated. Now, let's move on to a good question in the exercise. Right. We discussed the algebraic identities in the previous lectures in part 1 as well. Now let's do question 3 in the NCERT textbook. So this is a remainder theorem question, I believe. Find K if x minus 1 is a factor. And they've given us P of x, multiple P of x's. So let's take the first one, yeah. P of x, x squared plus x plus k. So if you remember, I told you for a factor, this whole thing has to be equal to 0, right? If I put x's value is equal to 1, remember the first step, keep x minus 1 is equal to 0, so x will be equal to 1. So P of 1 will be 1 squared plus 1 plus k, okay? And this should be equal to 0. So 2 plus k is equal to 0, therefore k is equal to minus 2. This is very easy, I hope all of you got it. Let's do another one. So we have to factorize. This is a factor theorem question. 3x squared minus x minus 4. So it's a degree 2 one, as you can see, so it will be much easier to solve. So we'll employ the splitting method. So instead of writing p plus q all the time, can I also write this as a sum, right? So I'll just write the sum for easier. Over here, what is the sum? Minus 1, right? And p into q is also the product, so can I write product? What is it? Minus 12, because 3 into minus 4, right? So what are the factors of 12? Just check it out. You have 1, you have 2, you have 3, you have 4, you have 6, and you have 12, right? So what will give me minus 1? Now, in these type of questions, what is the approach? We need to look at that. So if you can see, 3 and 2 is also giving you minus 1, but is 3 into 2 equal to 12? No. So we cannot use 3 and 2. So to keep looking. Then 4 and 3 give you minus 1. So will it work? Let's try. 4 into 3 is equal to 12. Yes, but we need minus. So can we say minus 4 into 3 is equal to minus 12? Yes. And minus 4 plus 3 is minus 1. So does it work it out? Check it out. Minus 1 and minus 12. So it works. So I will take minus 4 and plus 3. So 3x squared plus 3x minus 4x minus 4 is equal to 3x. Take everything common, what you see. Take 4 common over here, x plus 1. Be careful of the sign, okay? It's negative and negative. So I took negative 4 common, you get plus. We get 3x minus 4 and x plus 1. And just leave it here because they've asked us to factorize. Remember that. All right, let's go to cubic, one last cubic one before we head on to the second part of the algebra identities. So we did this part. I think the mic was unmuted, so most of you couldn't hear what I was doing. I was explaining on the way, but I'll just repeat it. So we had a cubic polynomial here. So we started with checking the factors of the last constant, which is +1 and -1. And we found out that +1 is giving us 0, so it is a factor. So then we put y is equal to 1, and then we took y is equal to -1, right? We took 1 there, so y -1. And then I did the long division method, which you all saw, the long division method, where I did this, where I got this as the quotient, okay? And then I factorize this, over here to get these two, okay? And then I just wrote them with this term and the last three terms. Since I was unmuted and most of you, no one could hear me, so I'll just do a cubic polynomial question again for the user's convenience. I'm sorry for the inconvenience caused. Most of you couldn't hear me, so I'll just do it again. Now the cubic question I will explain on the way. X cubed minus 3x squared minus 9x minus 5. Step 1, always look at the constant. What are factors of 5? +1 and -1. And then +1 and -5. All right, because it's a prime number, you only have two factors. So check p is equal to +1 first. Put x is equal to 1 first. Okay, 1 minus 3 minus 9 minus 5. What do you get? You will definitely not get 0. You will definitely get something -17 here. You get -16. Yeah, you're not getting a 0. So you cannot use this. So you will try with x is equal to -1. So -1 cube minus 3 into -1 squared minus 9 into -1 minus 5. You get -1. This will give you +1, so this is -3. This will give you +9 minus 5. You get -4 plus 5, plus 4, and that is 0. So x minus 1 is giving you, so you just bring this side, you get x plus 1, right? Remember this step. This is just a step, not much understanding to it. So now we'll do a long division method as it did in the last question. Same method, same way we're doing. It is a foolproof method. Please learn the long division properly, as it will help you later on as well. Just put x plus 1 there. And what I do is I take the first term and divide it with this term. First term by first term, that's method we use, x square. And then I multiply it, x cube, and 1 into x square, you get plus x square. And then you reverse the sign. Don't forget to reverse the sign. Actually, you're subtracting. So that's why the sign gets reversed. But for easy terms, I'll just say reverse the sign. Then you take the next term, which is the first term again, minus 4x squared divided by x. You get minus 4x. Write that there. You get minus 4x squared, and then multiplied by 1. Reverse the sign. Minus 5x. Bring the last digit down. And divide again, minus 5, minus 5x, minus 5, give you 0. So, but we're only interested in the quotient, like I said. We're really interested in this part because we factorize it further, right? We're going to do that exactly right now. All right. So let's factorize it. We take the sum. The sum is what? P plus Q itself, which I just said. So what is the sum? -4. And the product is PQ. I'm writing short form, -5. So what are the factors of 5? It's just 1 and 5. So you have to use these two, right? So what will give me sum? So -5 plus 1 will give me -4, right? And -5 into +1 will give me -5. So -5 and +1 are my numbers. So x squared +1x minus 5x minus 5. Why am I writing it like this? Because 5 will get common, so it's easier. So you can write it like this, or you can write other way, no problem. X plus 1 minus 5 common. Remember the sign, there's minus and there's minus. So careful of the sign. X plus 1. We take x plus 1 common, x minus 5, and x plus 1. But this is not your answer. You only have 2. It's a cubic. You need to have 3. So you use x plus 1 from here. So your final answer will be x plus 1, x minus 5, and x plus 1. This is your answer. For a cubic polynomial, we always have 3 expression, 3 factors, right? And so this is how we solve the cubic. All right, that's enough for the polynomials chapter. I hope most of you have understood. And if this has been helpful, don't forget to support the channel, Class for All. Please do subscribe to this channel, like and comment, and share with your friends if you think this was helpful. I'll really appreciate that. So thank you everyone for watching.